Hey, welcome to Chapter 5, and in Chapter 5 we are going to look at extending what we already know about sine and cosine and tan from the unit circle, and we are going to be applying that to a graph. So you can see even on your page right now that we have a axis that has been changed from being an x-axis to a theta axis, and all that means is instead of us considering just values of x, we're going to be looking at values of angles, which comes from the unit circle. So just to review one thing from the unit circle, that is any point that's on the unit circle has coordinates x and y, or theta y, and that corresponds to the cosine of the angle and the sine of the angle on the unit circle. So anytime we go around the unit circle, we know that the coordinate will tell us the sine and cosine values. So we're going to start by graphing sine, and I'll use my red pen to do that. And the first point we're going to look at is at 0. If the angle is 0 degrees and we label that coordinate, that means the sine value, which corresponds to our y value, is 0. So our first point on the graph will be 0. And on the y-axis here, I'm going to mark 1 and -1. Those are the values that we'll end up looking at here. All right, let's go around the unit circle now. At 45 degrees, our coordinates are not x, y, not cosine and sine, but if we remember right, that is root 2 over 2 and root 2 over 2. Now that's a difficult number for us to put on the number line, but that occurs at pi over 4, so I'm going to put pi over 4 here. And if we take that square root, it's something above a half, but not too much above a half. So I'm just going to estimate it to be approximately there. And then we'll go to pi over 2, which is at 90 degrees. And when I label that coordinate, that's 0 and 1. So that y value, which is 1, means that at pi over 2, the coordinate will be 1. Keep going around here to 3 pi over 4. And we're again going to be at root 2 over 2, so we're going to have some symmetry here. And then we get to pi, we'll be back down to 0 because the y-coordinate is 0. Now if we go in the negative direction, starting again at 0, we end up here, which again is root 2 over 2 and negative root 2 over 2. So now our sine value dips into the negative values. And then down here at negative pi over 2, we're at a situation where the sine value is going to be 1, in this case -1. So the y-coordinate's -1, so we're down here. And we end up with this shape as we continue on all the way to negative pi. When I connect the dots here, you can see we end up with a relatively smooth curve, limited by my abilities, and that pattern will just continue itself in both directions infinitely, and that is the graph of sine. Now if we take those same coordinates and we apply it to cosine, I'll use my blue pen here. At 0, the cosine value is 1, and then we go around, and you can see the values are similar, just starting at 1 instead of starting at 0. So cosine starts at 1, then goes to root 2 over 2, so it across here, then goes to 0 at pi over 2, then back to root 2 over 2, then down to -1, and then here, and if we go in the negative direction, the opposite happens. Again, not worrying about being perfect here in my points, but seeing just the general shape is the same as the sine graph. It's just moved over a little bit. Whoops, and there we go. And that also would continue infinitely in both directions. So really the same graph. You can see there's some points where they cross, and those points where they cross will always be at root 2 over 2. That's basically where we're looking at today. And then what we're going to do is we're going to apply some stuff we already know about transformations back from chapter 1. And if you get that, if you can graph from the unit circle, the rest of this stuff becomes not pretty easy. It's just manageable. We're also going to look at some other terms that you have seen before, but maybe more in science class than in math class. One is the period length, which is often called the wavelength, and you can see on this diagram here that it's just simply where does the pattern continue such that it begins to repeat itself, or where does the pattern start and where does it finish, showing one kind of unit of the pattern, and that's called the period. And I think we're just going to stop there, and we'll talk about the rest in class. And I think this unit will be just fine for us. It won't take us too long, and you'll find lots of success. So that's it for today. I will talk to you again soon.